Okay. Okay, go ahead and close this. Yeah.
Maybe I just copy it and run it in Chrome. It's okay.
Should be working. Okay. Okay, here we go. Yeah. Okay. Okay, now join.
Joe Mark.
Yes.
You get a chance.
Video I can remove.
Okay, so start the video and you can share it. What's that? What?
The link on the YouTube.
Yeah, I posted that on the CoprHD Dual group.
I got the recording. I'll give you a USB.
Stop. Hang on. You gotta. Oh, that's muted. Okay. Hang on. It should be fine. Okay, so go ahead and so screen share. Yes. Are you sharing screen? No, you're not. Go over here.
Yeah, I will go hangout. Your screen sharing.
Okay, but over here. Okay, where's the video running?
I say just say full screen.
Okay, where is the video running?
Here.
Okay. Okay.
Is that feedback in the recording itself or here?
No, I don't know. Actually, turn the volume.
I think he is.
Mohit? Mohit? No, it's not. Okay. Okay. You can talk. It's not. Oh yeah, it's not.
Healthy. Got some health food, guys.
It's like he's made out of things that used to be healthy.
Stay strong, until maybe half an hour, yeah. Because we might kill you, right?
He was very concerned about the granola place he had breakfast yesterday. See
Someday Rai is going to beat me up again.
it might not be the parking lot even.
Wait, what was it? What? Somebody what? Somebody got to beat me up. Oh.
All right, so do you want to just play the video and just talk over it?
Yeah.
Let's
Yeah.
if we'll upload the video later so that we get it on.
Right.
But right now we just need to talk over it so we can all hear you in the room, and then we can upload the video later.
Yeah, that's true.
I have the YouTube.
What?
The YouTube.
Huh? Yeah, I put it on the CoprHD.
That's the directly into.
No, it's not. It's the event page where you can view it.
Right.
Yeah,
Not the YouTube.
it's the same. It's the same feed. The event page shows the same feed. Here. Yeah. Yeah. See. You see it? Okay. What?
I gotta download software to be able to get into this.
Oh. Okay. Okay. So Anya, play the video, narrate, and then let's get it.
Okay, so I think basically yesterday we had the session on Docker integration, right? Are you guys able to see it?
You need to. Here we need to attach this guy. Okay, there we go.
So basically, we had a session yesterday on Docker integration, right? And there are various volume managers, and one of the major volume managers is called Flocker. So Flocker is basically developed by a company in UK called ClusterHQ, and ClusterHQ is, and this is an open source software, and the main goal is to have a common volume manager for multiple container organizations. So and they have some kind of a driver framework, and we can write drivers. So already a lot of EMC groups are working with Flocker to develop drivers. EMC, it's mainly driven by the CTO office, and the CTO office in EMC. People have developed driver for Scale.io and Extreme.io, and there is a driver being developed for Vmax as well. So one of our thoughts was to have a quick integration with Docker, is to write some kind of driver for Flocker for CoprHD. And if we do that, and we talk to the ClusterHQ people as well, and they are interested in it, in the sense that from their perspective, they want a larger support matrix, right? And so they want to be the common persistent storage layer for all container technologies. Like they have integration with Mesos as well, and they have integration with Docker. And as new third platform technologies come up, they want to develop volume drivers for all these, or volume managers for all these container technologies. And essentially then what they're saying is storage vendor just has to write a simple driver. And the driver is written in Python, and it's very similar to Cinder drivers, right? So most people, if they have Cinder driver, then with a very little effort, they can write a Flocker driver. So that's what we did. We did a proof of concept by writing a simple Flocker driver. And this demo basically does that, in the sense, it just shows how if you have a Flocker driver, then using Flocker driver, you are able to create volumes, attach volumes to containers and things like that, right? And once you do that, you can move You can move jobs. So basically now in this setup they have two nodes, right? And Flocker is a single control service. And so there is a control service for Flocker, and there are two compute nodes. Both of them have Docker. And in this, each of the compute nodes, you have to install this CoprHD plugin. And that plugin is essentially a small driver. And once you do that, then what happens is, as requests for volumes come in, each of these Flocker plugins in turn talk to the control service. The control service figures out where to place those volumes, right? And so they have agents running on each node, and the agent talks to the driver, which is what they call as the plugin. Plugin in turn talks to CoprHD. So for instance, now in this, what it shows is if you have CoprHD running, right, and then you have a project here, right, and tenant project, VRA, vpool, these are the basic setups you need to do on CoprHD. And once you do that, and you also need to add the compute hosts, right? So for example, all the compute hosts which are running Docker needs to be added here. So here, for instance, he has added two compute hosts. Both are running Linux. And in terms of networking, so this demo is for iSCSI, right? We haven't done anything for fiber channel yet. So I think fiber channel is going to be slightly more complicated in terms of how to do the zoning and all that. But as far as iSCSI is concerned, some of these complications are not there. The other thing is you have to pre-create some of these export groups. So these are the initial setups you need to do. You need to add hosts to CoprHD. You have to add the network to CoprHD, and you have to create export groups on CoprHD. So these are all the pre-creation setups that you need to do. Having done that, then now you go to the Docker node. I mean, you just list all the volumes. So volumes will be shown of type Flocker. Right? And here already there are some volumes. Now what he's trying to do is create a new volume. So Docker volume inspect is a command to inspect, get some more details of the volume. And here, if you look at the list of volumes, every time a volume is created, what we are doing is a volume gets created, Flocker gives an ID, right? And we just use the same ID and append Flocker to it and create that volume in CoprHD. And the other thing is, if you look at the volume WWN, right, and you look at the volume WWN on CoprHD, you can match it just to verify that the same volume is getting created here. So I think in terms of usage, it's going to be very similar to the demo that we saw yesterday, right? What the China COE team saw. That is, you go to Docker and you create volumes, and there is some kind of a volume manager, right? It could be your own native manager, or it could be Flocker. In either case, the volume would be created on CoprHD. It would be exported to your Docker container, and the Docker container can use that one.
So does it work with Docker containers, or is it Flocker has its own runtime for managing the containers?
Yeah, Flocker has its own runtime to manage. So it's not a direct integration with Docker, right? Docker integration is done by Flocker, and we are only integrating with Flocker. So Flocker acts as, so I mean, if you see in the picture, Flocker acts as a intermediary. Now he's running an app, right, using that volume. So every time you run any app, right, task gets triggered on CoprHD. First, there is a create volume task, then there is a export volume task. You can see now that that task is running. So now he's writing some file onto that data volume.
Do they have more than what, does Flocker have more volume management operations than Docker provides? Things like create, mount, unmount, snapshot, delete.
Yeah, I think they have a roadmap, like they want to add clustering support and things like that. Okay, and there is a concept of volume types, right? Similar to OpenStack, that or they call it something else. They call it service levels, storage profile. Yeah, they call it storage profiles. So a storage profile would be similar to your virtual pool. So you can create volumes with different kind of storage profiles. So for instance, you have gold, platinum, silver. You can create each virtual pool in CoprHD can be a storage profile for Docker containers. So if you have different containers, some containers need some quality of service, another containers need some other quality of service. So those kind of things you can do. So these are all these things are done as some kind of extensions, which Docker may not provide. So yeah, they are trying to add more features.
Anything tied to like fiber channel operations in Flocker?
Right now, I don't think there's anything tied to fiber channel. So for instance, um, you know, if your Docker containers happen to be running on fiber channel, then you need to. I mean, in a sense, your initiators, right? Whether they are fiber channel or iSCSI, they would be detected, and your attach operation would differ based on that. So I think currently we have done it with iSCSI, and the next step would be to try fiber channel. Technically, it is not very different in the sense, from a volume driver perspective, whether fiber channel or iSCSI, the driver remains more or less the same. It's just that some initial setups need to be done. Right? Now here, some of the steps in this POC were kind of done manually, like I told about creating export groups and all that. Now, when you get an attach request, if you have to dynamically add the host to CoprHD, right? And if the host does not exist, add it to CoprHD. And if there is no export group, create that export group dynamically in CoprHD. I mean, these are the kind of stuff. If you have to do, then some more work is required. But I mean, our Cinder driver, for instance, does it already. So I don't think it's
So for
going to
all
be very.
practical purposes, Flocker is very similar to Copperhead.
What's that?
It's very similar to Copperhead. So it's essentially a storage management controller for containers.
Yeah,
It is on
but
at the bottom line, it is using Docker runtime to manage the containers on a host.
correct.
And it has a layer very similar to open storage.
Yeah, I would say it's very similar to open storage,
To essentially
not
stitch
very
together-
similar to Copperhead.
Well, it depends on concept wise, not an implementation, right? So the whole purpose of Flocker and open storage existence is instead of going and managing each and every driver in in Docker, you have a layer in the middle to manage, give you that you know streamlined way of creating volumes, irrespective of what backend you have.
True.
So open storage is trying to do the same thing. Flocker is trying to do the same thing. In fact, when you look at the Flocker description, it is essentially the uh, volume management layer for containers.
Yes, it is a volume management layer for containers.
Then you have one more layer in the behind the scenes with Copperhead.
But you don't necessarily have to.
Yeah, in this case, it is behind.
That's what you are probably trying to say.
Exactly, that's what I'm
Conceptually, it is really a side thing.
Yeah,
I mean, yes, you can integrate Flocker and Copperhead, but you don't necessarily.
Exactly, that's where I was going, right? So
It's just yet another layer.
it's another layer. So I mean, my preference would be not to have multiple control planes to manage storage backends. Let have one control plane to manage, because in reality, I don't know how. It's good to do this just as a way to make sure it's available in. There are a wide variety of implementations. So you have Kubernetes, you have Mesos, and now you have Flocker, and then you have open storage, and you have Swarm. There are lots of other. Every all these frameworks are trying to actually get to one manage. It's a container management with the high availability, scheduling, and all that good stuff. And almost all of them are looking at the storage management as an integral part of it. Um, so it's okay to integrate Copperhead across all these things, but at some point we have to look at how do we move this into up one more level.
I mean, I think part of the discussion here today should be about what is the best way to approach persistent storage in containers. Is it Docker? Is it open storage? Is it direct connection to Docker or whatever container platform is being used? Do we go with Rexray, or do we say that Copperhead is the all-encompassing storage controller that works with containers or whatever compute orchestration platform you're working with? I mean, what is the direction we're going? I would say that's the thing we need to answer, or at least bring a discussion.
Yeah, so I think this was actually done by one of our engineers in Bangalore who is not even part of the corporate development team. He's in the escalation engineering. So the point is that it can be easily done. Integration with Flocker can be easily done.
Actually,
and
almost
that's
all
just
these
a
drivers
first
have a
step
very
problem.
similar footprint.
Correct. So maybe that is just a first step for us to get into this world. If we have to then, implement all of these features inside Copperhead, in the sense, allow, storage profiles, clustering, volume movement, or when a compute node goes down, it's going to involve significant amount of investment on the part of, on our part to do all this stuff. So I think that's a decision we as a community need to make.
Now there is a distinction though. So take Mesos and Kubernetes. The Kubernetes gives you a container management framework that includes high availability, scheduling, and so on. As part of the Kubernetes spec, they defined what it means to be aware of network attached volumes, persistent volumes. So the Copperhead will integrate into it as opposed to having an open storage in front of Copperhead or having Flocker in front of Copperhead. I don't see the value. Doing is okay, but just from a viability perspective, from someone consuming it, it's like you have multiple controllers managing, providing the container volumes to the containers. It's like, just think of, Nova, then you have the Cinder, behind the Cinder you have Copperhead. Somewhat similar implementation here too.
Yeah, so I think maybe it's just a first step. May not be the final goal, but
Yeah, I think that's the discussion we need to have. What would be the short-term goals? Obviously, to just go enable everywhere.
Right.
And you don't know which one is going to be successful, wildly successful. Mesos is pretty popular, Kubernetes is pretty popular.
So then how much work are we talking about as far as integration with Kubernetes or Mesos, some of these other scheduling?
They're fairly trivial. For the basic volume management operations, it doesn't mean the spec is mature and complete.
Right.
So, you just have to do whatever they have currently. In fact, Docker did not have these persistent volume support till 1.8 and 1.9.
Okay.
Which is just a couple of months ago.
Right.
So they are rapidly evolving. We just need to be making sure that we have the drivers for all of them. Whichever is successful, we are still there and everything. But my preference would be not to go after the controller behind controller and have that solution. While it's okay to enable it, let's see how far it can actually take it.
correct.
But
what do we see for, so we've seen now a direct driver for Docker, we've seen this Blocker integration, we saw what the open storage guys were doing yesterday. Do we see these in the short term being something that we would stick into maybe the add-ons extras repository, saying, hey, if you want to do an integration, go grab this sort of prototype level driver that we have in here and take a look at it? Or
For Flocker, they have their own repository. So what you do is, once your driver is ready, you submit to them, it goes with them, and it remains there, right?
Okay.
So we don't even have to keep it in our repository.
they
We
bundle
want the
it.
source,
Huh?
though, presumably.
They do bundle it.
Yeah,
Okay, but we got to have the Copperhead driver source code on the Copperhead Git repo.
yeah, we can keep it there as well. I mean, even Flocker is an open source repository, so yeah, I mean, you can keep it in both places, not an issue.
I mean, the thing I like about all these integrations, definitely there is a merit in doing it.
Yeah.
There is, you get to actually raise the visibility of Copperhead for the container side of the world.
And the cluster
Specifically, there is a
HQ
Copperhead
people are
driver.
also interested in it.
Yeah. It's
Cluster
popular,
HQ
so-
is very interested in it. See, Cluster HQ,
The
the
Flocker.
guy, the
So,
Flocker developer.
yeah. So the advantage is that there are two major benefits in doing it. One is it gives us exposure, broad exposure. So I was looking at Kubernetes, for example. It had I think it had Kubernetes or Mesos. It had open storage as one of the drivers. Won't it be cool to have Copperhead as one of the drivers, right? That's what I want to get to.
Yeah.
So that's a visibility part. The second element is there is a team in EMC. EMC code have set of drivers that they are writing
Yeah,
for
Rex Ray.
Docker, Rexray.
Yeah.
I'm looking at it and say, why do you need to do that? Copperhead does that for you. So you just need to write a Copperhead driver. There is no need to do anything beyond that, right? So I did not realize that till yesterday or day before yesterday. I was looking at it and say, oh, EMC code Rexray, and they're doing the Mesos. There is something called Docker volume data interface, driver interface, and there is there is a Docker side of the drivers for Extreme IO, Vmax, and the Scale IO.
Yeah.
Sitting there and say, no.
You'll have to ask them why they're doing that.
Well,
So
there are two sides to that. One, it kind of allows different thoughts and stuff to come in. But at the same time, when you really look into today what you have in Copperhead originally came through many years of 100+ people, like at least about 3 years of 100+ people working on it. All the cost of learning the arrays, refactoring our code multiple times, and then all the labs, the testing and stuff and all that, that's how you get something like Copperhead. So yes, Copperhead sort of came out from Viper later on, but it came with some sort of mature functionality that is trying to test stuff. A lot of these other layers that's coming out, I've always seen the compute part everybody gets in, because that seems to be the easiest one to handle, tackle, compared to networking and storage. When it comes down to storage, when it comes down to networking, it's a huge cost to really come up and say, it's easy to do. I mean, you need the labs, you need the certification and all of that before you really come up with something serious. But at the same time, it will stop people from, writing different type of drivers and approaches and things. I mean, I agree with Reddy. Is on one hand, we continue to promote, that show how easy it is to do it with Copperhead. But then when it comes to making changes or an investment in Copperhead to align with, with the container or a future technology, we should see about eliminating the number of controllers, things like that, and
Indirect drivers.
Right?
Those are the two overarching themes, right? Number of controllers and direct drivers. But yeah, I think that's what I think for the short term, the goal is to have these drivers anyway for Copperhead for all these frameworks.
Yeah.
Make it bundled, make it be very visible with in all these websites. Then figure out which one goes faster, which one is popular.
Sure, I mean, Blocker is popular now, so why not have an integration? Even if we don't think it's the ideal, at least it gets us in front of more people, which, it's give and take there, but.
True. Yeah, I think that's the part.
There's a bit of risk there, though, I think, because
Sure.
in my opinion, what you're kind of saying, what this kind of discussion is really about, is kind of sharpness of vision. Like where are we going? And so I feel like there's a bit diluted if you're talking about, hey, our goal is to be have a single controller. Like they're just talking about like a single control plane, but we're adding plugins that place us in another position farther down the stack. I don't think it hurts per se in terms of a little bit of hey, here we are, but I do think it hurts a bit in terms of what exactly is our focus? Where exactly are we going and how to get people on board?
I mean, we need to decide on what our focus is, what our vision is, and just lay it out there and start building it. But I don't think we're there yet. I mean, I don't think you're wrong, but we need to kind of figure out what that is.
Yeah. We need to see these things as the computing orchestration frameworks as opposed to computing and storage, right? So that's the way I look at it for the Kubernetes and Mesos. I do not look at Flocker and open storage as the computing orchestration framework. They are trying to be Uber storage controller for containers. That's where I have a little bit of a conflict of scope between all these three projects.
True.
So if it's okay with you guys, I was going to ask Sean if from an OpenStack Cinder perspective, the discussion that we are having here, like what's the view, from a Cinder perspective regarding containers and some of these other middleware or other type of containers or controllers springing up? How do you guys see it?
Well, as far as Cinder as it is today, the idea of having another controller, based on the history of Copperhead, was actually shot down when the Copperhead driver was proposed for being a Cinder backend. There was a lot of discussion about it, and it came down to not wanting to have a storage abstraction layer calling a storage abstraction layer to manage the storage. So in that respect, it's very similar that we did want to just keep one control plane and not have multiple layers in there. Container-wise, there's projects like Magnum that's theoretically can tie into. Not anything specifically within Cinder that's working specifically on container backend support.
Okay, I think we have discussion around this.
Okay, is this something we want to put in the parking lot for later discussion, or do we want to just bring this?
I think the short-term goal is to let's make sure the drivers are bundled as well as available on our feature report.
So our next step, I think, in this is to make sure it works with fiber channel as well.
Still work involved. But
There is
have those radar drivers.
Yeah, there is a work involved in terms of getting it work with fiber channel and then submitting it to Flocker. So I think it will be there both in our repository and their repository. And then we'll see. I mean, it doesn't prevent us from doing a direct integration.
Exactly.
So, these are not exclusive.
The driver, because typically they only post the code for the cluster HQ supported backends, and it is up to individual vendors to publish their drivers somewhere else. And one other thing to keep in mind on this is they also are going the direction of OpenStack of not enforcing yet, but strongly encouraging any backend drivers to also have a CI system in place. So if they make that a hard requirement, that'll be an additional burden on the top of the community to have to support this.
Interesting. Yeah. That's a risk of going through layer 1, layer 2.
Mm-hmm.
You are at the mercy of what they decide.
Yeah, that's true.
Is it getting traction? Cluster HQ, Flocker, I mean?
Blocker seems to be popular. I mean, I don't have hard numbers to back that up. I can only base that on what I hear from container discussions that I see on the web.
There's a lot of.
Yeah. But it's all very nascent and new, so what's popular now doesn't mean anything for like 6 months or a year from now.
True.
Yeah, I think the other, in the parking lot, what we need to include is, out of all these integration interfaces, or these key interfaces that are missing, these are all basic stuff, like create, delete, and mount, unmount volumes, and they have a little bit of snapshot. Do we need more interfaces? If so, what would that be, and how do we need to work through these Docker community as well as Kubernetes, Mesos community to enable?
Yeah, I think they have added concept of storage profile, right?
Yeah, well, like Flocker has that, but
yes, they haven't added a concept of, say, availability zone, for instance.
Exactly.
So I mean, those are some of the missing things there.
It's there in the Kubernetes. Kubernetes has
Kubernetes may
Mesos
have
has
it. Yeah. So I mean, these are all the different things that they need to add. The concept of, they don't have quotas, they don't have projects or volumes.
Yeah, exactly.
So there's a bunch of stuff that is still not there. It will take time, I guess.
No, I mean, I don't mean that way. What I meant was, rather than having them actually drive those interfaces, we could be the active participants to influence those interfaces. This is the theme behind the open storage discussion. Not because it's a controller to controller, but rather influence the interfaces that are comprehensive enough to, have a richer volume management feature set as opposed to just get menu.
And I think the open storage guys sounded like that.
They are very interesting.
Oh yeah, they would actually.
There's a strong interest.
They actually help us.
Came through the Intel discussion, slightly different, pull them into cover. They're very interested. I don't know about the Flocker.
Even Flocker guys said that we had one meeting John Mark set up with them. So they are interested in looking. So as I said, from their perspective, they want to show a large support matrix, and that's the reason they are interested in Copperhead. In fact, once they claim Copperhead support, then they can say, "Here now I have support for 20 array." Something. So yeah, that's their interest. They might be interested in working out on these backlogs or new interfaces or whatever our suggestions are. Yeah, so that's going on.
Okay.
Okay.
Cool.
So we jump into the OpenStack.
Sure. Who all needs to be brought in on that discussion?
Yeah.
Okay. Who else? Anybody else?
So the way we have planned is I have a set of slides. We'll just give an overview,
Okay.
and then uh, Peter, I think, has a demo on the QoS stuff.
Okay.
And what else?
Yeah, that was it. So I'll present a couple slides to
Yeah.
John Mark.
Kurt has
You
a
need to
set
advocate
of
something.
Okay.
So it'll be like 2-3 things.
Okay.
One
so,
after the
so
other.
only one remote person, right? Shing.
Yeah.
I'll bring her in.
So this is an invite to Kurt, so we can share.
Okay. Kurt, what's your?
You mean my Gmail?
Yeah.
Kurt, C-U-R-T, dot E as in Edward, dot Brun, B-R-U-N-S,
Uh-huh.
at Gmail.
Okay.
So much. Not everybody's.
Okay. I've sent you an invite, so you should be. Okay. And so you're going to share slides?
Yeah.
Okay. Are your slides open? Okay, cancel. Okay, are your slides open?
Yeah.
You may need to close something. Maybe you have too many apps open. I don't know.
Just share the whole screen.
Yeah, you can do that too.
Yeah.
Yeah. Yeah, there you go. And then before you get lost in it. Okay. For some reason, I'm not seeing your. Is anyone? Did you get the invite?
Is it visible on the?
No, that's the problem. Like.
Yeah. Yeah, I mean,
Here, I just sent you your Gmail account.
Okay.
Yeah, I'm gonna kick you out. Oh, hang on a second.
it's able to see it.
Okay, yeah, so. Can,
Pura is there, no? Pura, can you see it?
no, can't see anything.
Mm.
I think, well, why don't you kill Why don't you kill your Hangouts, and then let's see if you get back in. You need to hang up. Hit the, go ahead and hang up. And then click on it again. See if that, because it was working before
Yeah.
for a minute. Make sure you kill your mic. Okay, thanks. Yeah. Go ahead and go to the screen share. Okay, take your slides. Or actually, you can just do some. Okay, good. Ah, there we go. Okay, that's working.
Yeah, showing up.
Okay. Now, if you want to. It's fine. Okay.
Mm.
But what's that?
Is anybody absolutely married to Google Hangouts? Or can I go ahead and set up a WebEx account for CoprHD? And that way we'll just.
That's fine. Except
WebEx seems to work for everybody, even inside firewalls, right?
yeah.
Because this doesn't work from inside the firewall, at least at my job. Is everybody okay? Okay. I'll set it up as soon as I get access to my computer.
There you go. Okay.
Yeah. On WebEx, it's like $20 a month. And you get the good one, which has voice over IP also.
Separate account, you're thinking about this.
Just get a personal account.
Yeah, the only problem is live streaming. You can't do that.
Sure, but I'd rather be able to run events easily. This is becoming, like, there's too much downtime. We're losing.
Okay.
Okay, so let's go through this. Basically, there are two parts. One is, I was planning to cover only the block service for OpenStack. We talked about it during the last summit, and so just an update as to where we are and what are the next steps, for which we do need some discussion. There is a proposal which I have on how do we have some kind of a coexistence, right, between the block service coming from Copperhead and block service coming from Cinder. So that's something we can discuss. The other thing I added is because of yesterday's thing, I think Reddy was saying we need some way to ingest drivers. So there is some thought on how it can be done. So those are the two things we need to discuss this. Now, just a recall of what is our objective for block services. Like, I think everybody seems to agree that we don't want to have a controller on top of a controller. And so what we are now trying to do is how Copperhead can be the storage controller for OpenStack. That is, be API compatible with Keystone, Nova, and all that, so that directly support all these arrays using OpenStack APIs. And so what we want to do is implement the APIs directly in Copperhead, and without any change to other OpenStack components, everything should work with Copperhead just as it was working with Cinder. Now, so we discussed this, and to implement, obviously now the effort required wasn't very high because we already have all the REST APIs on Copperhead for create volume, export volume, and so on, which you see on the left-hand side, the native REST API. And for supporting the OpenStack REST API, or what we can call the Cinder's REST API, all we have to do is open another port and write a small translation layer which converts from the Synthos REST API to the native REST API. And after doing that, by keeping the rest of the stack the same, we are now able to support simultaneously both the APIs. So you could be supporting APIs coming from the left side or the right side simultaneously. And as far as the current status is concerned, the left-hand side, I'm showing all the. It's a joint work between EMC and Intel. Right? Left-hand side are all the basic operations like create, attach, snap, clone, etc., which is already completed, and this code is already in master now. And there are only a couple of things which are pending from EMC side, which is the create volume from image and some kind of testing using the Tempest framework. Intel is working on QoS, which is almost complete, right? And we are ready to put it in master. Of the other three items work in progress, the first one, again, automatic service registration, we should be, I think, finished by end of this month. So at least these two features will go into the Aurora release. And there's work going on glance interface and create image from volume. So then about the items which are yet to start, Keystone V3 interface. So Keystone V2 is what we support right now. V3 interface, support for volume statistics, implementing backup support through SIFT, and some interface to serial. So these are, kind of, you could call backlog items. And so that's the current status of this whole effort.
So on the backup and accelerometer, I think we need to have a broader discussion as opposed to just purely focusing on OpenStack. These two things need to be, and even maybe a little bit on the stats too, needs to be the core part of the framework and what needs to be done before we talk about the OpenStack. So the backup doesn't have to be Swift only, it can be S3 too. It can be some other native interface as well, right?
Yeah, so I think volume stats may be more straightforward.
Yeah,
Keystone V3 and volume stats may be more straightforward.
Yeah, so there is an interface level discussion, but there is a framework level discussion that needs to happen as well. On the left, the things that have been completed are the ones that you already have all the plumbing in the framework, so you are good. But in the backup case, where is the plumbing? Go into pluggable backends, S3, Swift interfaces. Then when your backup REST API is coming from OpenStack, you're just flowing through the same, framework layers too. You don't want to do one-off for OpenStack only. That's my point.
Correct. Yeah.
Same thing with the metrics and monitoring.
Yeah. So for Swift, I mean, of late we have added some plumbing for object support. So there is object support being added.
Did we have a design review on that one? I don't remember.
But yeah, there is no, but that's more from a discovery standpoint, right? Discovery of object interface and creating buckets, that kind of.
Where is that happening? Is it in the Southbound SDK scope or is it when you say discovery?
It's a northbound API.
Okay, let's say I want to back go on, right?
No, there is no backup support, right?
Exactly. So that's a discussion.
Correct. Backup support is not.
But for us to do the backup, you also have to have a plumbing for the discovery, because when you do the discovery, you're not discovering just object backends. I mean the volume storage backends only, right? So you may be discovering the object storage backends. So then you need to be able to say object storage backends, you can create volumes, you can actually use it for backup. So there is a mechanism for pooling and use that as a way to say, here is a backup pool that has either S3 interfaces or Swift interfaces or some native interfaces. So that's what I mean by framework changes.
Yeah, I think backup is a complex piece.
Right.
The other thing is about this coexistence. So we had, so we have this issue of either block service can be coming from Cinder, right, or it can be coming from Copperhead. If you have both of them, right, if you have both Cinder working as a block service API and Copperhead working as a block service API, the issue in OpenStack is currently, the very first block service that is detected in Keystone will be taken, and the subsequent ones are can, ignored. So what we need is an ability so that multiple block services can coexist simultaneously. Because if that happens, right,
But it's not a keystone problem though. It is the consumer of that service.
It's a consumer of
so
the
if it is Nova.
Yeah.
Nova is searching for a specific token, let's say volume v3, and then you get a service endpoint, and then you're connecting to that service endpoint.
Yeah. So what we need is some changes on the Nova side so that it is able to understand, hey, I have some volume types which are coming from Cinder and some volume types which are coming from Copperhead. And depending on which volume type I want to operate on, I need to go to that corresponding service.
You probably have to do that in the Nova scheduler because upfront you don't know what it is. So the scheduler is the one that has to go figure out pluggable backend controller scheduler kind of a thing. That's what basically what you're looking for.
Yeah. So we want, so it might require some upstream changes, right? But
I don't know if the community will like it.
yeah, but if we can push that, right, and if we can get it working, right, then what it means is that if you have some existing OpenStack setup where already, I have some drivers, and I am using Cinder, and I have already a bunch of volumes, and now I want to introduce this additional service, Copperhead, right? I can do it in a non-disruptive way by allowing you to continue your existing things, right? And this is some kind of an additional service you have without disrupting your existing operations on the left-hand side. Add this additional support on the right-hand side, and both can coexist and work. And then it's up to you. You want to use Vmax or Vplex, you use these Copperhead drivers. You want to use some of the say 3PAR or NetApp block or whatever, for which Copperhead does not have native drivers. You can continue to use your existing Cinder drivers. So both can coexist, and both can work simultaneously. So that's the kind of deployment model, which I think we should aim to achieve.
Yeah, I think there are two things that need to be looked into because there is a rippling effect. It's not just Nova only. Anyone that is actually using the Cinder REST APIs need to have a switch in place. Not the Keystone. Keystone is just a brute force service endpoint REST API call, right? Nova has to worry about all the Horizon volume API calls need to worry about. The glance needs to worry about that part. Kilometer has to worry about, things of that sort, right? And there are a lot of other projects under the OpenStack umbrella that are not really part of the core, and we can need to look at that too. So I don't know I think it will be good to really just to take a good pulse at the what does it take to do this. The other element, which is more in the operational side, is I'm not sure if the customers will have appetite for managing two different controllers in a real production environment. What I have seen so far, without naming the big customers, these are all big enterprise IT shops, they really lean on one that can manage everything. At least that has been a very preferential feedback so far. But if you have OpenStack in test and dev environment that is top to bottom just OpenStack native, you're not going to put CoprHD in the mix. You may just use the, just the stock EMC drivers in Cinder too, right? It's too much of a hassle for somebody to put two different frameworks and figuring out how they work in OpenStack. OpenStack in general, it's not like a very simple, stack, right? There is a complexity already. Then having another one, and it's not simple either. So I'm more thinking from an operational viewpoint. It's a very daunting task for someone to take on both. But if Shane is there, it will be good to hear from what he thinks.
Yeah, so I want to hear your views on this. And in fact, if we do this, it will help even to have two Cinder endpoints. So I mean, it's not just coexistence between Cinder and CoprHD, but let's say I have a very large data center and I want to have two block services. Both could be Cinder or both could be CoprHD or whatever combination. Even that, would be a useful thing to have.
You want to try see if there is a way to the cell region combination, and see if you can use that as a construct to say. I know it's not really a pure region managing your storage resources, but can you use that pseudo construct as a way to say, for this region, just go to CoprHD kind of a thing, just like Active Directory domains, right?
Well,
This is a fake one for all practical purposes.
so I understand the technical idea. Fine. What are the use cases? What are the customers that we think are in need of this sort of setup?
It's a brownfield environment, right? In the sense, I already have a working OpenStack setup, right? And in that setup, you're saying, hey, I have a CoprHD controller which has, so many additional features, and it supports OpenStack. They'll say, all right, how do I use it? And then when you say, oh, by the way, for that, you need to deploy a completely fresh OpenStack setup. People may not, appreciate that.
One thing, this doesn't get us closer to maybe some of the strategic things we'd like to do, like add vPlex on top of NetApp or 3PAR.
Yeah.
There's no connection here for that. So the
Right-hand
driver
left-hand side.
ingestion idea, if we can figure out how to make that work, might allow that.
Yeah, I mean, it just operationally simplifies it. That's all I'm after. Because if you add more overhead and baggage and more layers, the level of interest quickly goes away.
Okay.
Because you're adding more barriers. That's where Hura was going on the use cases. If you add more barriers to entry, it becomes very challenging.
Well, does it also go the other way, that people having, I mean, would that CoprHD instance still be usable outside of the context of OpenStack?
Yeah,
That's the intent, right?
Yeah, I think that's
in the
where.
picture we are not showing other stacks, but technically, surely on top of that CoprHD you could have a VMware stack.
Something else,
Yeah, sure, absolutely.
So let's say you have nothing today, neither CoprHD nor OpenStack. You just have a traditional, enterprise IT. In that scenario, either one can fit the bill, right? So you can put CoprHD and manage your storage backends and then figure it out. So the second scenario is you have a CoprHD already managing your storage backends. Then you want to bring in OpenStack. How do you do that?
Right, I can see that scenario.
That's I see that scenario probably more. The third scenario is you have OpenStack top to bottom, going and putting CoprHD. I doubt it.
So that means we also need like a migration strategy so that you could be running CoprHD with regular users, servers, and then switch to Keystone midstream, right? That would be something we also need to do.
Now, why would you want to switch? You want to do an incremental add, right? You already have a setup, you have some apps running, you have some things which are already running. You want to do an incremental add, right? And not a rip and replace kind of system.
Right.
I mean,
but,
if
so
people
you're-
want
if
to
you're
do
bringing
it,
in, if you're bringing in OpenStack, you have to set up Keystone.
yeah, of course.
So, and then you have to change your instance of CoprHD to start using Keystone so that they can authenticate to each other.
You are not changing keys, CoprHD to start using Keystone. CoprHD might be using LDAP and AD. All you are doing is adding one more authentication server, right? That's not a rip and replace.
Right.
Yeah,
So-
Keystone is
Keystone
completely
is an
autonomous.
additional,
Okay.
It's a security
additional
authentication
authentication
provider.
provider, right? When you are adding OpenStack to CoprHD, you're not saying I will drop VMware or Hyper-V, right? I mean, that's just one more compute stack. So likewise, Keystone will be an additional authentication provider. So,
Sorry, go ahead.
yeah, so I mean, that's the way we incrementally add things. We add compute stack, we add arrays, we add authentication providers. Now you think from OpenStack perspective, you have a working infrastructure, you want to add one more block service. We should be able, I mean, in theory, we should be able to do it.
Yeah, I'm not after the technical implementation, I'm more after who cares for it.
Right. So if you have a mixed environment already, you can see the value there. If you're not an OpenStack user but you're interested in adding OpenStack, you can see the value there. If you're an OpenStack user already, is there value to adding CoprHD to the mix?
I don't.
Okay.
Love to
I
hear
mean, those are
from,
the questions we have to answer.
love to hear from Sean and the rest of the folks. but I don't
Oh, the
see-
OpenStack guy. Hey.
I don't see that.
Okay.
Right.
I need to mostly stay a passive observer here. I'll say, this doesn't seem too interesting to me right now, this coexistence. I think we're gonna have a much better chance of being able to do that existing CoprHD deployment where you're adding OpenStack. That looks much more interesting to me.
Exactly.
If this is where end users want to go and give that feedback, then you're gonna have a little better chance of bringing that to Keystone, bringing that to Nova, wherever changes need to be made on the OpenStack side. Say, look, we have OSU wanting to do this, or we have, if there are actual users asking for this functionality, then there's a better chance that changes can be made to support it. But if it's just, well, CoprHD wants to be able to do this, you're not gonna get any traction at this point.
That's,
Okay.
one voice is better than two voices. Or two voices better than one voice, I think. Sorry.
Okay, so then the other thing was the ingest, right? So ingest again needs a discussion, but in a way we have support for ingest, but this is an indirect way of doing ingest. So what we are doing, and this is already incorporated, is we are able to use Cinder as a southbound provider of arrays. So if you add Cinder as a storage provider, right, and that Cinder already has drivers for some arrays, right, then CoprHD makes REST API calls to Cinder, and Cinder in turn creates volume and so on. So that is a mechanism by which we can add any array which has a Cinder driver into CoprHD. That array then can be used in a non-OpenStack environments, for example, VMware or bare metal or Microsoft. So that is an indirect way of ingesting a Cinder driver into CoprHD. If we have to do a direct ingestion, right, that is, don't use Cinder, directly use the Cinder driver, then, I mean, we tried that approach, but what happens is those Cinder drivers, import some Python libraries, and those Python libraries in turn import some other libraries. There is no definitive set of which libraries will be imported by which driver. So if you have to support all the drivers, so for example, you support a couple of drivers, you add the third driver and you suddenly say, hey, some libraries are missing, I need to add those. And those dependencies become very difficult to manage. Besides, the driver is tested in a specific environment. Right? If you want to use the driver out of that context, right, and use it just as a simple Python file, then it's possible that all the scenarios are not well tested. Right? So you take a vendor's driver and then use it directly in CoprHD without Cinder. That vendor is very likely to say, hey, I've never tested it without Cinder, so how can I support it? So that is an issue of using the driver directly without the environment in which it was designed to work.
So it will be the same problem. If you were to look at what Flocker is going to do or open storage, or it's the same issue. So I essentially I take the Flocker shim layer, plug that into Extreme IO driver. You could say, hey, I've never tested it.
Extreme driver is tested with Flocker.
I mean, just a scenario of you could, because you're consciously testing that end to end. You can do the same thing here. It is essentially you have a small layer that's translation layer to talk to the Cinder, driver Python class entry points. No different, right? Well, there is a need for testing, but you are not going to do that testing. That's not your job. That's not CoprHD's job. It works does not mean it is ready. When there is a need for the customer pull, that's when a storage driver vendor need to get that act. It's not, I don't think you want to take on that burden of making sure that this end-to-end flow works and all that stuff. It is just that a shim layer is there for you to support it, and if someone wants to take advantage of it, it is the driver vendor and customer who need to get their act together, right? I don't think we'll be able to kind of provide the Cinder pluggability, Cinder driver pluggability, and then do all the CI stuff and all that. That's not the intent. Our hope and pray is that CI thing is solid enough that the driver is very stable. Our entry points are, and up into the CoprHD is solid enough that that is stable. Having two stable things does not mean it is totally unstable, but there is a need for someone else to own that, and that got to be the driver owner.
Yeah, but what about
we don't have to do that proactively. We do it only when there is a need for that driver OpenStack CoprHD combination, and then it is being used in some customer environment.
Yeah, but what about the libraries? I mean, there are a bunch of libraries which are imported by.
But those libraries are not conflicting, right? You're talking about Python libraries versus Java libraries. So I fail to understand that challenge. The conflict of two mutually distinct set of libraries that you're dealing with. So I don't know the specific concern there.
I think what he's saying is in OpenStack, let's say a Cinder or any project, it has its requirements. And then, of course, all of OpenStack has global requirements that has some of all these requirements. If he goes into just the one driver code and he's looking at that driver's requirements, he might miss some ABCD that is needed. So, does it make
Every
sense
driver
to just load
includes
all
a
of
different set of libraries, right? And those libraries in turn include some other set of libraries. You don't have a definitive set of libraries which you must carry with you if you want to ingest.
I'm not saying you have to package it. So maybe you're onto after the packaging element. I'm not saying you have to package it. I'm not talking about packaging at all. You don't want to be in that business. All you have to say is, hey, CoprHD has a shim layer to actually talk to the Cinder driver directly, and it works with maybe kilo release. And we have tested that as part of our CI thing with a couple of drivers, and use it at your own risk or have some disclaimer there. Good enough. Right? I'm not saying just all those things.
Right, and then it would be up to the individual driver.
When you go to the customer and do a POC and it works, and then they see that that is the right thing to do, then you just create that pull indirectly with the driver manufacturer to do that validation.
I'm guessing that's pretty much how, like on OpenStack, from going to the OpenStack Summit and just seeing how people work.
Yeah.
Half of the people there are the customers who said, well, I have this hardware and this software, and I just want to make this thing work with that thing. I'm going to do it myself. Right? That's what he's describing. I mean,
right.
I know we're used to know we gotta do the whole thing and we gotta have the whole solution and they're gonna give me a call and then I'm gonna have to go there again for free and do all of that. But on the open source side, it's okay. I mean, it's okay to say, because I'm not understanding, and maybe you can. I mean, I'm not very familiar with the Cinder side of CoprHD. That's my bad. When you say you have to import a bunch of libraries and stuff, like why? Because I thought the Cinder driver for anything, for like an ERA, that's just a piece of software you run on some machine.
Yeah, the
With
piece
an
of
ERA
software.
behind, and then CoprHD over here, and it just talks to that. But why do we need to like move libraries?
Because a piece of software imports some libraries. And so, and that library imports some other set of libraries. So you need to have all those libraries on your node if you want to run that driver.
It's fine.
I don't see that as a problem. I don't understand why.
Yeah.
Why is that a problem?
It's not a problem.
Yeah, of course you need to have it. Of course you need to go through the structured way of pulling all those libraries. Of course you need to have a document on where to go and look at what are the dependencies, how to install it. Those things need to be there. I'm not saying, but I don't see that.
We don't allow, I mean, there is no way for someone to log in and import libraries onto CoprHD node, right? At
You don't have
runtime.
to do that.
So
But
maybe
why would you
build
need to
a-
do that? That's my question. I mean, isn't it just CoprHD is sitting on this computer, the driver is sitting on that computer, and this guy talks to that guy through
No,
some
they
API?
both run on the
I
same. They
understand
both
that.
run on the same.
Why?
One second,
Why
let me
don't
try
you
and
put-
answer what he's driving at, whether it's a real issue or not. I think he's saying, I'm gonna have that CoprHD block, go and get that HP3PAR, IBM SVC, etc. drivers, bypassing the Cinder piece, which would normally have installed and got everything. Is that what you're saying?
Yeah, I
So
will
he's
copy
trying
the
to
driver
relocate that
onto the
Cinder
CoprHD
driver.
node. I'll copy the Python driver onto the CoprHD node.
Why?
Because that's the only way I can ingest it, right? I mean, I have to use it directly.
Why don't you put them in a container or
Huh?
something? Why don't you put them in a container or something with a library fetcher thing?
Yeah, you can put it in a container, but then how do you make a remote call to that container? It has to be on every node. If I have 3-node installation, I need to have the driver on every node, right? So that if one node goes down, the other.
Yeah. So
You have to physically include the driver.
No, you just know where that driver is.
So that particular driver is not HA,
There's
where
a
the
register.
CoprHD is?
Well, there is that.
Yeah, then the solution will be like this only. There is a remote call. It'll be pretty much like this, right? That you have a driver running on another node, right?
yeah, the problem with just taking a driver and running somewhere, it is just basically a Python class.
Yeah.
It's not a REST API
Yeah.
here in the middle.
Yeah, I
So
get
you
that.
could do that technically.
So if
very
you use a
likely,
REST
that's
API,
exactly what Docker guys do. So
Right.
Docker guys, what do they do if you want to create a volume, right? So it is basically talking to a management, very small management, socket API to say, okay, just for the driver registration, but behind the scenes, it's not a full-blown driver, right? And it is just saying,
So
okay,
could we
here is
leverage,
a driver,
could we leverage one of those Docker?
very similar. yeah.
Dockers.
So we have to look at those elements and see if there is a way to just take advantage of a little bit of that and figure out isolation. So you don't have to worry about, running on the same node or same process context. But it is doable. So even if you have to run in the same process context, I think you can do it.
So
It's not like there is a big conflict of libraries because
a
it is
Cinder
Java.
driver is not the equivalent of a SMIS provider. It's not a service. It doesn't talk to the outside.
it's not a service.
Driver class.
It's not a service. If you wanted a service which supports REST API, then this is how it is.
Right,
A
Cinder is
dotted
that
line.
service.
Yeah.
But it's
So,
not.
I have a question. What we're currently doing here, right? We're using the Cinder API, right?
Yeah.
And that's a really well-defined box storage API.
Correct.
And we're ingesting drivers through that interface. Doing that. And what Sean talked about yesterday a little bit was Cinder is trying to detach itself or decouple itself from Nova and trying to work outside of OpenStack as well, which is what we're doing here. Seems like those two things dovetail pretty well, right? Like we want to use Cinder drivers, in our instance, and they want to let Cinder drivers work outside of OpenStack.
Let's get married.
I'm just saying, right? That seems like the goals are similar.
Yeah.
And we already have a well-defined API interface with Cinder, so I don't know, pulling drivers, detaching them from the Cinder, the Cinder implementation.
That works
You can
a
still
little bit
install the
easier.
Cinder, right? So you're just
Yeah,
not
so-
using the Cinder
So that's
runtime.
what I'm doing. So
Yeah.
what I'm
Not
doing is only
isolated.
Keystone and Cinder, not the whole.
They- Most of them depend on other Cinder services. Some of them, even though we highly discourage it, some actually access the Cinder database. But they are not isolated pieces of code that you can just take out of Cinder and run something else. But yeah, if there's some way that we can find some way to have these services work together, then I think we have the best of both worlds.
So there are lots of such dependencies which I know. Extracting the driver out of that Cinder environment and using it.
Let's do this. So take one driver. Let's take HP3. Just take one of the most popular ones that we don't have in Copperhead, but in Cinder. Let's parse through it, see what it takes. What would be the challenges? I mean, I have written the Cinder driver for Ceph. There is no database in the middle. The only piece that I'm worried about is there is an asynchronous MQ, what is that? RabbitMQ events flowing back and forth.
Correct.
That's the only tricky part, but the rest of that stuff is being straightforward. So let's pick one driver, see if we can actually solidify maybe a good example. What would be the technical hurdles to take that and make it happen? Because now you have the northbound interface that understands the semantics of volume types and all that stuff, QoS, AP things. I think you can actually punch through the Copperhead framework to get to that Cinder driver and with less effort. But let's spend some time in understanding the challenges rather than just debating. Right?
Well, I guess what I thought I just heard from Sean was he was saying that a lot of the drivers, number one, interacted with other OpenStack services, and number two, interacted with the Cinder database. Or are you suggesting we're going to emulate the Cinder database API, whatever that is, as well? Or
That sounds like a rabbit hole.
No.
yeah, so what is the point of what you're
So
proposing
I don't
if we
see-
already know a priori that some of the drivers absolutely won't work with this approach?
So I don't see the driver talking to the database and
There are some that have database calls inside the driver.
okay. So that which ones are they? Just not all drivers.
I don't have a list, but.
Not all drivers. But not all drivers do that. It's not.
Yeah, and
So
we
it's
are-
not a standard.
It's discouraged.
Yeah.
But hey, you can always abuse it if you want to. Right?
So is there something wrong with this approach? Well, I mean, I'm not seeing a lot of drawbacks in this approach compared to the previous one. It seems like the right way of doing things as far as.
Which approach are you saying?
This one right here. Basically,
Using just Cinder plus the driver.
yeah, basically a translation layer.
It's heavier weight, I think, is the main thing people don't like about it. You know, if you're not already an OpenStack customer, then you've got to pull in an OpenStack environment that you didn't need otherwise in order to get there. More layers, kind of the same arguments we've been having. 2 control planes.
Storage management.
It's a heavy
Storage management.
control plane layer that requires a lot of deep expertise, understanding. So operationally, something goes wrong. How do you figure out? Just taking Cinder and figuring out why the volume creation failed is not an easy task. So just going through that entire flow operationally in a typical IT environment, no way.
But are they going to like it that much better if the Cinder driver failed with inside Copperhead? I mean,
Well, at least you know where to go, which logs to go, and where it starts, where it ends. You know the exact flow.
yeah.
You are not trying to figure out which flow it is that you need to be after and which driver is managing which controller. And it's an expertise that's these stacks are pretty deeply complicated. You know, not from a developer viewpoint, but from an IT viewpoint, they require
Either way,
a
it's
lot.
pretty complicated.
But if
Just
you're
the driver and storage backend is complicated. Forget about the layers above, right?
Yeah, but if you run into issues, are you more likely to find help or better documentation in Cinder than trying to parse through Copperhead? I mean, parsing through some of the Copperhead documentation is pretty hard compared to some of the other projects out there.
Are you making a case for not using Copperhead? Are you
No, I'm
making a
saying
case
that
for
using this translation layer, even though that's more of an operational cost first, better, you know, down the road than having to, you know, figure out just the Copperhead piece.
Yeah, just think of this way, right? So take a stock Cinder driver. You're probably looking at 1,000 lines of code. Take a stock Cinder implementation with the whole slew of things. You're talking about several thousands of lines of code. Would you rather just go with the smallest piece that you can actually observe, or you're going to go with it this big or this small? Which one is more manageable? That's what we are after.
Many of the Cinder
If the translation really is that simple, then it's a different thing.
If we supply that dotted block, the open stack block with Cinder and Keystone as part of CoprHD, and the user still has all the installation issues of putting his driver in there that he would have, but doesn't that mitigate some of this fear of the multi-stacks from an operational standpoint?
If you can bundle it, I think it might, reduce some of the pain.
Oh, you're talking about bundling?
I
think so. The other option could be
with CoprHD.
Yeah.
Right, if we ship.
I mean, if you're so, the other option could be you can essentially containerize Cinder. I think that's where Kurt and Sean were going. You can take the Cinder and make it a container and just deploy it and you consume it. Maybe, but it's not as simple as that. The problem is you have the high availability, you have the scalability. It doesn't work that way, unfortunately. Because it's not just a simple translation from want to create a volume.
Yeah.
Who
Plus
do you
the
need to talk
drivers
to, then
don't
it's
do all the
fine.
various things we need them to do.
Yeah. Like the open storage guys were talking yesterday, he's basically saying, hey, I have a container that is just doing the translation, but the translation is extremely lightweight.
Okay, so maybe we will explore that.
Let's look at it and see what if
Some
there
of
are
the
technical
drivers, for
hurdles, then we should
instance,
not.
are just translation layers into their own CLI, right? So what it means is, if I have to use the driver, the Python driver calls the CLI. I need to install that CLI. So HDS, for instance, they have a CLI, and so you have to install the CLI. So there are some
I would separate those two things in. What does it take for the end-to-end thing working? What do I need to do? Versus what does it take for me to just enable that capability? If that enabling is such a painful process and it's not sustainable process because every rev you need to worry about certain compatibility, then it's not worth it, right? If you're going to lose certain critical capability in the driver, then it's not worth it. So there are lots of obvious decisions we can make based on the data. Right. Because if you want to install CLI, if you're running a Hitachi app line, the backend, and you need a driver and you need a CLI, they will have to do that today too, even with OpenStack. You're not going to get CLI just because you have a Hitachi driver in it.
Yeah. So yeah, true. So that's okay. So then I have a bunch of backlogs, which is something that we identified during the last summit. So I'm just scanning it here. These are some of the stuff that we need to take up, and maybe we can debate now or debate later. This is again part of the backlog which we had identified last time to get corporate working with OpenStack. One is on this support for Ubuntu and CentOS. Other is coexistence with OpenStack services. That is, can we get OpenStack services and corporate services running simultaneously on the same node? Then CI tools integration. And last is, of course, ingest any better solution. So any thoughts on any of these things?
So the Keystone is the one that was a big one that we talked about. What we talked had not the actual authentication happening in the Copperhead. Get rid of that authentication, use the authentication provider, And then package Keystone is the one that we had some discussion, because rather than having authentication provider for all these things, you can have a Keystone that actually authenticates with LDAP, AD, and its own. So we had a lot of discussion around it. I don't think we settled on that's the right direction, but have you guys looked into what does it take to get rid of the homegrown authentication in Copperhead? And what does it take to actually hand off that authentication to Keystone as the authentication provider? And what does it take to actually take that and package it? The biggest element is going to be a packaging problem.
Yeah, I think when we talked to, internally it looked like there is not much appetite for using Keystone outside of OpenStack environment. So that's where, people are still more comfortable directly using LDAP or AD, not Keystone. In OpenStack environments, there is a good acceptability for Keystone as an authentication provider. Not so in non-OpenStack.
I think the question was,
So coexistence.
if you don't have
is what we-
OpenStack, if you're going not going, I don't know. Is there a
So coexistence is what we support today. I mean, it's like, yes, you have LDAP, you have AD, and you have Keystone. We don't have a situation where, hey, yes, you can use LDAP and AD, but you know what? You need to use Keystone as your first point and then put LDAP and AD under Keystone.
Yeah. So there is that element of authentication. There is the tenant management. We're mostly talking about the tenant management. Why does it need to be the Copperhead? So if you're going to use OpenStack, your tenant management is probably going to be in the Keystone.
Right.
And if you're going to use, let's say, VMware vCenter, it's going to be in vCenter. Why do we need to have a native tenant management capability, which seems like a little bit of out of sorts compared to the storage management aspect? Then there was a question about, hey, I know I don't have OpenStack. I need to get to tenant management. How do I do that? Then we talked about, okay, just take the Keystone and just use it as a standalone entity.
Yeah.
So that was the discussion around it.
Since people know that we already have tenant management, now we cannot push them to say, hey, we don't have tenant management, so you need Keystone. And it's difficult to sell at that point in time to say you need Keystone. Why? Most people
Sal was
say, why do I
suggesting
need
package
Keystone?
it.
Huh?
Sal was suggesting bundle it, not
Package Keystone.
Yeah, suggestion was just package it, and rather than, so anytime there is a, Keystone is a very, there is a vibrant community in OpenStack. Keystone enjoys that, and there is a lot of innovation happening.
Right.
This is not a value prop for Copperhead, right?
Right,
So
so
that
why
was
would
the
we
whole
maintain
discussion
our own?
around it. It's not like a critical capability and a value prop for
Fair enough.
Copperhead.
I can see that.
So that was the discussion.
I mean, the question would be, can Keystone, does Keystone have the capability to handle everything we need?
Well, and I think another thing that's going on right now is we have some customer push to handle other types of external authentication providers. In other words, integrate with external IDPs and support SAML. And so that's another customer request that we're seeing and looking at how to sort out. So I think there's a number of things to figure out with regard to, okay, that's more or less delegating to an external authentication source, but it's not Keystone.
I think the Keystone use case was only for places where you need to manage the tenants, but you don't have tenant management around it. So I think we are mixing the security authentication and tenant management. Security authentication, I don't think you will need something homegrown in Copperhead, right? You are always delegating it to Active Directory, LDAP, SAML assertions, and Keystone. That's clean part. The tenant management was the one that was a little bit tricky.
And Reddy, can you just tell me, ignorance here, what do we mean by tenant management? Is it like quotas? Is it?
It's creating all these tenants to projects and tenants.
Project tenants, you assign quotas.
Okay.
So
The resources, the
you do the
there be lots of QoS,
All provision resources are under the umbrella of a tenant, meaning just some collection of volumes, and then you have to map every user that logs in to some tenant within.
And then you need that too in Copperhead, right?
Yep.
And you already have something in CoprHD.
Yeah. That's
To
interesting.
capture QoS, to capture quotas, you already have that. Is there like an API that's the same whether I use Keystone and your Copperhead, I can extract a common API so that whether you use your Copperhead tenant manager or the Keystone it works?
So
Is that
what
a
we have
way to
done
go?
for
It's very
the,
confusing today, right? So you have tenants, but the currently with the Keystone, that's the backlog. That, so essentially the tenants in Keystone get pulled into tenants in Copperhead. So they look, feel exactly like what it is.
Okay.
It's not the case today.
no, we do have that, right? I mean, in the sense, we talked about the block service API for OpenStack. If you are using, Copperhead as a block service in OpenStack, then you are in an OpenStack environment.
And you need to tune into OpenStack tenants, not your own tenants.
Yes. So at that time, what happens is Keystone is your authentication provider. Users log into Keystone, get their tokens, and then use the tokens to talk to Copperhead. And when they do that, right, then the tenant management will be done by Keystone.
Yes.
Right. When you're in a non-OpenStack environment, let's say VMware or bare metal, right, and in that scenario, we don't use Keystone, we use either LDAP or Active Directory. And then you can either use it as a single tenant environment where you just create projects, right? Or you create a multi-tenant environment where you take an Active Directory group or an LDAP group and you can associate it with a tenant, right? Or you can associate an entire Active Directory with a tenant because we support multiple AD instances. And then you can have some kind of an isolation between these tenants in the sense one tenant user cannot see other tenants' resources. And
So in the existing one,
Hmm.
I haven't played on the latest drop, but
Hmm.
in the existing one, with the Keystone, there is a tenant A. You're basically cloning that tenant in Copperhead and using that, right? Exactly the same name as opposed to, yeah. So that's basically what we are saying is we don't need to do it. We just delegate everything to the Keystone. But I think from a priority perspective, we got to get the Keystone integration with OpenStack anyway.
Correct.
Once that is done, maybe we can circle back and say, okay, what do we need to do with the tenant capability in Copperhead outside the scope of OpenStack? See what makes sense. Too much scope otherwise.
So I think I have taken a lot of time. I'll hand it over to Kurt for the QoS discussion and demo. And we can take up this backlog item discussion maybe later or tomorrow.
Yeah, maybe add it to
5 right now?
Huh?
Yeah, take 5 minutes, sure.
Yeah.
So maybe add it to the parking lot.
Backlog priority, I think. OpenStack backlog priority. Keystone.
The key is
There you go.
sitting bottom so that he
Secretary.
doesn't have to write down.
Another rate. I thought that was obvious yesterday. You noticed. I only wrote the first part.
That's right, you just got started.
Everything else was planned. I know what I do, I just start things, then I walk away.
Somebody eat the donuts, please.
To save you from temptation. Take it over to the student center or something.
I don't know.
And help yourself to these fancy water bottles. Really, they were like for some college activity, and I gave them out, and that's what's left over. I've had boxes of them. And these were for recruiting at OSU. They're the recruiting people gave them to us. They stick on the back of your cell phone, and you can put business cards in it. I think they're completely useless. So, but feel free if you like it. I won't judge you. So.
You're really selling it.
Hey, Ura, when was that?
And if you have questions on what those are, which I can see it. Not on the camera.
Oh, actually, yeah, that's
very end. Bavarian, people put
Yeah.
Bavarian. Some sort of Bavarian build thing. Old fashioned.
Japanese.
Something. Twist, the chocolate.
Put it in somewhere else.
Yeah,
Thank you. You are my, like, donut buddies. We'll keep each other away. So am
Fair enough. That's you probably right.
So, obviously, really curious.
How many classes did you have?
Outside.
Yeah,
It's pretty big. Completely architected.
There's kind of music technology moving right here, or it's not like computer science, but the values and technology program, it's called like the future. I can see it every year program. There's like 6 or 7 grades that are saying that I do stuff like they play content. Michael Hayes. It's a pretty popular computer. But yeah. We found a picture of the guy who's in charge.
Camera. There's a camera.
Are you allowed to? Yeah, I mean, you're part of the true location program.
Yeah, I can't do anything there.
Watching these Google groups wait to find you.
I feel that it's the fairs, you know, we go to the state fair and stuff, and they like take pictures of those on the rides and all that stuff.
I mean, yes, from a, why do you, sure, I look, once you get into details, like, okay.
Serious?
Yeah.
If you just take a picture and you decide whether or not to buy, like, really I'd like it to not happen because there's so my kids decided something like that, just don't use be comfortable with it. I enjoy that.
That's funny. Just the looks on their faces, that's all I want.
I don't really care about the other part.
I think initially that's what it's going to be, but at some point it has to, I mean, I don't know, my kid, it's something that has to kind of merge.
If you can go over to the student center,
Right.
or students will
Basically, no one just walked.
just fucking drum up.
Yes, it can go like any number of ways that are confusing to everyone involved, but I want to make sure you guys are. Okay.
Yeah.
So are you set up or what?
Yeah.
Okay, so everything, okay. Okay, and then you have this, okay, your great.
And then one of them actually did it.
On the OSU
So that's last.
Make sure you're
That's somewhat different.
and then you're really good. You're good to go. All right. Unless you want the camera, but I think you want to share slides. So you got a slide. What do you have?
So I got a slide, and I'm gonna show CoprHD dashboard.
All right. So tell me if you're set. Thanks, man. You want to start? I'm gonna start the broadcast for now, and then
Yeah, we're starting.
and then we'll start again.
Right or left or something for 5 minutes.